Good day, Cassia Nation. In this video, we're going to solve quadratic inequalities using fx991ex of Cassia class Ws. So, when we say quadratic inequalities, it is like quadratic equation, but we are using the four inequality symbols, which are less than, greater than, less than or equal to, and greater than or equal to symbols. So, it has four forms. We have ax squared plus bx plus c greater than 0, ax squared plus bx plus c less than 0, ax squared plus bx plus c is greater than or equal to 0, and ax squared plus bx plus c is less than or equal to 0. Wherein a, b, and c are any numbers such that a should not be equal to 0, so that the degree will not be equal to 1. So let's try to answer an example. For what values of x will the quadratic inequality x squared plus 5x plus 6 greater than 0 be true? So, when we say solving quadratic inequalities, we are trying to solve for values of x that would satisfy the condition that it is greater than 0. X squared plus 5x plus 6 in this example must have a value that would be bigger than 0. To solve that, let's press menu, then choose using the arrow key, the down arrow key. Let's find the inequality mode, so that is beta mode. Press equal sign. So we have here option polynomial degree. Since it's quadratic inequality, the degree is equal to 2. So press 2. So we have here four options. These are the forms of quadratic inequality, but in our given, we are using greater than symbol. So we will choose 1. Since x squared plus 5x plus 6 greater than 0 is following the form in option 1. So press 1. Then we need to identify the values that we need to input here. And these are simply the values of a, b, and c. In our example 1, we have x squared plus 5x plus 6, which means that the values of a, b, and c are 1, 5, and 6 respectively. So we have to input 1, press equal sign. Second will be the value of b, which is 5, then press equal sign. And last will be the value of c, which is positive 6, press equal sign. Then after encoding all the coefficients for our quadratic inequality, we press equal key. So we have here x is less than negative 3 and x is greater than negative 2, or simply negative 2 must be less than x, which means that we can assign any values for x to make this inequality true, but we cannot choose negative 3 and negative 2 to be the values of x because that will not satisfy the condition, because it will be 0 and not greater, 0 is not greater than 0. So, next example. For what values of x will the quadratic inequality 5x squared minus 3x minus 6 is less than or equal to 0 be true? So again, we press menu, then we choose inequality mode, select 2 as our polynomial degree because it's quadratic. Then following the form, we have 4 options. In our given, it is less than or equal to, so we will choose 4. Then again, we're going to encode all the coefficients of the given inequality. So the value of a is 5, press equal. Value of b is negative 3, and the value of c is negative 6. Then to show up the values for our variable x, we need to press equal sign. Okay. So we have here the result. This means that in order for this quadratic inequality become true, then the values of x that you need to assign must be greater than or equal to the value, which is 3 minus the square root of 129 over 10, and it must be less than or equal to 3 plus square root of 129 over 10. For the last example, let's try to solve for the values of x that will make the quadratic inequality 2x squared minus x plus 5 greater than 0. Okay, so to do that, let's press again menu and choose inequality mode. Select 2 as the polynomial degree. Since we are given greater than symbol, we need to choose number 1. So choosing number 1, and we're going to input the values of the function. So 2x squared minus x plus 5 greater than 0 has the value of a, which is equal to positive 2, value of b, which is negative 1, and value of c, which is positive 5. Then to show up the values, we press the equal sign, and you will see here that the result is all real numbers. So it means that for the quadratic inequality 2x squared minus x plus 5 greater than 0, all the real numbers are possible to be assigned in this inequality to make the statement true. Thank you and have a good day.